So for today's notes, we want to start with the essential question: how do atoms form molecules? For those of you that are playing along at home during this year, it would be page 126, and we did this on May 7th. And without further ado, here we go. How do atoms form molecules? To start with this, what we need to first do is define what is a molecule. And to do that, what we will do is take a look right here is the definition of a molecule from our previous unit was this. It was more than one atom that has been chemically bonded. So let's draw an example of a molecule. So you'll have one atom. So in this case, I drew an oxygen atom. And then we're going to add some hydrogens to it. So hydrogens will be chemically bonded onto the side. What we have here is the two elements, hydrogen and oxygen, but when they chemically combine, I picked one that you probably know. What they do is they form the H2O or water molecule. Now what we're looking at here is how do the atoms actually form those molecules, and that's through this process right here, where the hydrogen is not just stuck to the oxygen, but it's like really chemically bonded. And so what we take a look in this unit is the idea of how the chemical bonds are created and where they come from. Okay, so where do these chemical bonds come from? How does the hydrogen attach to the oxygen? What we have to do is we have to run it through a specific process. So the question I'm asking here is, how do the molecules actually form? Now that we know what a molecule is, it's when one or more atom has been bonded together. How do those molecules form in the first place? And what we do is we run it through what we call a chemical reaction. Now what is a chemical reaction? First off, what I do is from this point forward in my notes, instead of writing chemical reaction all the way out, what you're going to get is just chem RXN. So RXN stands for reaction. A chemical reaction is this. It's when two or more substances, interact to create a new substance. Now in order for this to happen, the molecules were bonded together in one place. So what we have to do is we have to take that molecule and rip it apart. So we have to break some bonds in the first place. The atoms rearrange themselves, and then new bonds form. And so here's the key thing we want to take a look at is the atoms are together in the first place. You got to break them apart, you got to rearrange them, and then new bonds will form. What we did in class to demonstrate this is I showed a chemical reaction. It looks something like this, and I'll try to put together a video to throw it there. It was called the whoosh bottle. All right. And when we saw the whoosh bottle, what we saw happening is you see me strike the match. Now that's me adding energy to the first place. So I had to add energy, and that little bit of friction is what breaks apart the first chemical bond between the match and the elements that are inside there. Once that gets broken apart, it interacts with the stuff inside the air and creates new bonds. And when it makes new bonds, that releases energy, which then is allowed to break the next one apart. And when we put this all together, you get the big flame like you saw during the whoosh bottle. Now with chemical reactions, we can't actually see what's going on. So how do we know that a chemical reaction took place? If we can't actually see the atoms or the molecules, then how do we know that bonds are being broken, atoms are rearranging, and new bonds are formed? And the reason we know that new bonds are being formed is because there's a creation of a new substance. So during the whoosh bottle, I started with a little bit of alcohol, and then when it ended, I ended with carbon dioxide and water. And if you were in the classroom, you would have been able to smell that change, that we had created something new. So how do you know that a reaction is taking place if you can't actually see the atoms rearrange themselves? What we do is think back to what you saw during the whoosh bottle video there. You saw that light was produced. Okay, this is often an indicator that a chemical reaction is taking place. What else did you see? You saw, well, you wouldn't have seen it, but if you were there, you would have felt it. Then heat was being produced during that reaction as well. And if you think about it, light and heat are really just two forms of energy. So if there's a production of energy or energy being released or even taken in, there's a good indication that the chemical reaction has taken place. All right, the other one that we notice is there can be a change in odor or taste. In the room, we notice, or you can smell when something is burning, because burning or combustion is a chemical reaction, so that change in odor lets you know that things have changed. Now the taste one is something that might happen at home if you take a drink of milk If it doesn't taste like milk, it's probably because a chemical reaction is taking place and that milk has soured. Now, I do like to do this here, and just to remind us that we're not actually going to taste stuff inside the class. The next one is the production of gas, and this is how the whoosh bottle gets that whoosh sound in the first place, is all this gas is being produced and it's forcing its way out of the bottle. If you mix two liquids together, what you might see instead is you might see bubbling or fizzing, and this would let you know that a new substance had been created, a gas that wasn't a gas before, and now it's coming out. One of the stories we say is if you're ever at home, there's two cleaning chemicals you should never mix together, and that would be bleach and ammonia, because when these two chemicals interact, often in a lot of cleaning products, what they do is they produce chlorine gas, and chlorine gas is very damaging to humans. In fact, it can kill you quite easily. And so if you're ever doing something at home and all of a sudden it starts to bubble or fizz and you weren't expecting that to happen, you should probably leave the room, because there's a good chance that maybe a harmful gas was being created. So let it air out before you go back in there. And the last one is a little bit harder here to understand, I think, in your everyday life, but this is called the production of a solid precipitate. So I'll throw a picture up right here for you to see. So when you take a look at the solid precipitate, what happens is you take two normally clear liquids, and when you mix them together, the things that were liquid end up starting to create little chunks of solid, and those little chunks of solid make it going from being clear to being cloudy. All right. Now, any one of these doesn't necessarily mean a chemical reaction has taken place. However, what we do is we call these our indicators of chemical reactions. So if you see one or more of these, there's a good chance that the chemical reaction has taken place. The other way to know for sure is to actually do some tests to see if there was actually a new substance created, and there you would test its chemical or its physical properties in another way. So that is part one here of how do atoms form how do atoms form molecules. Atoms form molecules through the process of a chemical reaction. That's when two substances interact to create a new substance. The bonds are broken, they rearrange themselves, and new bonds form. The bond that we're talking about is what's inside that molecule that holds the two atoms of different elements together. And by creating that bond, you create a new substance. If you have any questions, come see me in class.